So, welcome to another great episode of Java Boom. I'm your host Georgi Wisniuk, and today I'm going to show you how to write a program that can print a range of prime numbers for you. So, this involves having the user input a range, for instance 4 to 73 as an example, and you get the entire range for that set of prime numbers. So, with that, we're also going to introduce a wide variety of functionality. For instance, we're going to introduce a concept of wrapper classes. So, what are wrapper classes? Remember in my previous lesson, I did mention about making distinction between primitives and classes classes have additional functionality. In this case, a wrapper class wraps typically a primitive or another class around it to enhance the function, to add additional functionality to the primitive or that class. But in this case, we're going to use the integer class. We'll also introduce the concept of if statements. What are if statements? You probably guessed it. They are conditions. So if this condition is fulfilled, move into this block of code. We're also going to introduce while loops, which are similar to for loops. In some ways, they're easier to understand. And we're also going to introduce the keyword break, which is used in loops. Basically, they're used to get out of them explicitly if you need to. We're also going to introduce the keyword modulo, symbol modulo. And what is it? It's basically division between two numbers, but it will return you only the remainder. So, for instance, 5 modulo 4, or better yet, 5 modulo 2 equals 1, since after division you get a remainder of 1, but 4 modulo 2 is 0, since 4 divided by 2 divides evenly and you get nothing as a remainder. So, we're also going to introduce utility classes like math. What are typically called utility classes? They're classes where you have static methods that perform single functions for you. They don't typically store any data for you, but they fulfill a specific function for you. That's what they call utility functions. So, with that in mind, let's get started with our lesson. So, to build our program that generates prime numbers, we have to create two new primitives. Int start range and end range. We're also gonna create a new primitive called status, which is used like a flag. And by default, it will be 1. And we're also going to use a counter called num, starting at 3. I'll explain this later, but keep that in mind. We're also going to create a scanner class, which we use to get user input. With a reference int, new scanner. And we input the standard stream. And so we get the range from the user at this point, and we assign it to a string with a reference called range. So we call in get next. So next, once we get the range, we have to parse it, because typically the range is a number, then a hyphen or TD, then an end number. Hence, that's why I created two primitives, keep in mind, called the start and end range. So, first we have to assign the start range. So, this is where we get to use the integer wrapper class. Inside the integer class, there's a static method called parseInt, and basically what it does is to convert a string into an integer. So if you have a number inside a literal, for instance, it will convert it to a primitive for you. Parse int and range, and we do a split. Now, what's a split? Split is a method inside a string class, which you can pass a delimiter to separate into multiple strings. Since, for instance, in a range, we typically have a hyphen between two numbers. So we use the hyphen to separate those two numbers. So you can type it, you can just use directly input the hyphen as a literal, or you can use regular expressions, which is a little more complicated. And I'll talk about this in a different episode. So we do hyphen. And this returns you an array of strings now. So we have to get the first one. So we do open and close bracket to get the first element of that array. And there you have it. We get this start range, and then we need to get the end range, which is pretty much the same, except we just get the second number in this once we split. So now we have the start and end range from the user. Our next step is to start building a loop. Now, what do we need a loop here for? So to get all the prime numbers for a range, we have to loop through all the numbers, so consecutively. So before we do that, we just do print out a line. Tell the user the first prime numbers are this and this. Now we have a special case here, and this is where the if statements come in handy. So if the start range is at 1 or more, we typically include 2. So we do a check here, start range, if it's greater or equal to 1, and then the number which is we set at 3 at the beginning is greater than the start range. So if both of those conditions are true, then we print out 2. If not, then this line will be skipped by the program. So there's also another way to do if statements, which is a shortcut. We can use the question mark symbol. So let me show you. So num, we assign it to num greater than then start range, and equals, not equals, sorry, question mark, then num and start range. So what does this line does? So basically, this question mark is basically before this is basically a condition. So if this is fulfilled, satisfied, then we go on to this. If it's not, then we use this. So basically, if the counter is greater than the start range, then we keep the counter at 3. Otherwise, we assign the counter the starting range, whatever the value is in the start range that the user inputted. So this is basically an if statement, but it's a lot shorter. So now we get to creating our while loop. While loop is similar to a for loop, but you can use only one condition inside the open and closed parentheses, which is typically just for the counter, to check the counter. So we're at the counter, and we keep looping if then counter is less than the end range. And inside we put the status as 1 and a number and the counter gets incremented by 1 every time the loop ends. This will force the loop to end eventually to prevent a infinite loop. So now what's the status here? We're going to use the status, this primitive, to check if the prime numbers are divisible. Remember, prime numbers are basically numbers that cannot be divided by any other number except themselves and 1. So we're going to use the status to check if we found a number in the range for that specific number that is divisible. So if it is, we assign 0 here. If it's not, then we just keep 1. So with that, we're going to have another inner loop here, which will check all the ranges for the specific number that we using the counter for. So I'm going to start with counter 2, which we're using J as a counter for this inner loop, and we'll continue until J is greater than the math.square-root counter. Now what is math.square-root? It's a utility class that I mentioned that has all static methods at the, remember, static methods are methods that are available at the class level. You don't have to create an instance of them. So they're available all the time. You just have to call the class followed by a dot, then the method will be available there. So what this math is a class is part of the Java platform. You can use basic math functions here, like square root, power, number to the power, those functions are available here. So after that, we keep incrementing this J counter, and inside this block we have our if statement, which will use the counter modulo J and equals 0. Now what is this condition? What is this condition is? It's basically we check the counter, basically the range of all the numbers that we provided as input. We check if they're even. If there's an instance where there is no remainder, that basically means they're successfully been divided evenly with no remainder. So that means they're divisible. So we check, we add the status. We add the status, change the status to 0. And we break. Now, what is this keyword break again? Let me remind you. Break is basically it will immediately get out of this for loop. There's other keywords we can use, like continue. Basically, it will continue to we'll skip that moment in the loop, but will continue if you need it be. But break in this case will get out completely out of the loop. So once we get out of the loop, we can, after all this is done, we can simply check if the status is not 0. If it's not 0 at this point, after checking all the numbers that are potentially divisible, then we're safe to assume this is a prime number. Then we can simply print a line counter num. So with that, let's build it and see what happens. Oh, and I forgot. Let's add a small comment for the user, for instance. Please enter range prime numbers. As an example, 4 to 78. So, with that, let's run our program. So, the program is asking for a range. Let's do 6 through 79, for instance. So there you have it. 7 is a prime number, 11, 13, 17, and it goes all the way to 73. So there you have it. We built a program that runs and generates a range of prime numbers for you. So I hope you enjoyed our lesson, got some insight on a variety of functions. Until then, take care.